Okay, guys, this is Unit 2, Lesson 1. It's decimals as equivalent divisions, equal divisions, fractions. So just understanding the place value of decimals and thinking about those, and then thinking about how those relate to fractions. The best thing I can say is if you can say the numbers and their place value, and you can say a fraction out loud, then you can say the equivalent decimal and fraction. Okay, so let's take a look at some. Fractions and decimals, they're just special kinds of numbers. They tell the number of parts of an entire whole. So when you guys look at these pictures down here, right here, like number one whole, if we divide it into parts, right, we have fourths, 4 equal parts. 1/4 plus 1/4 plus 1/4 equals 4/4, or one whole, right? And then we have one of each of those, okay? Again, same with number 2, fifths. Well, when we go down and we look at decimal notation, it's no different. Think about a dime. If you have a dime, you have a tenth of a penny. Well, that could be written as 1/10 right here, 1/10 as a fraction. You guys see that? 1/10. Also, it could be written as a decimal, just like we would normally see it. So 1/10 as a fraction, 1/10 of a dollar, 1/10 being the tenths place value. All of these things are said exactly the same way. So if we start saying our place value accurately when we have a decimal instead of saying 0.1, I don't ever want to hear 0.1. I want to hear 1/10. Because when I say it as 1/10, I instantly can see the connection between these two items. Okay, so I want to say 1/10. I say the number and I say its place value. So same over here. If I have a penny, it's 100th of a dollar. It takes 100 pennies to make a dollar. So it goes, when we write it in decimal form, in the hundredths place value. So 100th of a penny, or 100th of a dollar is a penny, okay? If I say this number, when I say this number right here, I would say 1, so I just say the number, 100th. I say its place value. Where does it sit on the place value chart? Okay, same with thousandths. Thousandths would be a tenth of a penny, a piece of a penny. So if I took a penny, and like the picture shows here, I divided it up into 10 equal pieces, a tenth of a penny would be a thousandth. So again, when I say these numbers, when I say these decimal numbers, the most important thing is that I actually say just the digits that I see and then their place value. Okay, so 1 dime equals 1/10. 2 dimes, 2/10. 3 dimes, 3/10. 4 dimes, 4/10. You guys see, if I say the fraction or if I'm saying the decimal, I'm saying the exact same number regardless of which one I'm visualizing when I say it. Okay, 10/10 is 1 whole. So this is the only one that changes on, right? This very last one, 10/10 actually is 1 whole. Okay, and so those are different, and that's just understanding that. Okay, so let's look at some of these and think about converting them. Okay, it's just saying them. Honestly, to me, if you say it first, it's easier, but that's just my opinion. 349 thousandths, right? So I said that out loud, and now I'm going to write it. That means I know my last number has to end up in the, oops, let me switch from highlighter to a pen, how about? I know my last number has to end up in the thousandths place value. I've got to have my decimal. It doesn't matter whether I put a 0 in front of it or not. I can if I want to. I don't have to. You guys will more often than not see me skipping that. I don't tend to put a 0 in front of my decimal because I don't need it, and I don't do unnecessary things often. 6/10. I know that 6 is going in the tenths place value. 58 hundredths. So I know that that 8 is going in the hundredths place value. It's wherever your last digit lies, 58 hundredths. 27 thousandths. I'm going to actually work backwards. Okay, I know I need my 7 and my thousandths. I've got a 2. Right now I'm only in the hundredths place value. That means I need a 0. The 0 after the decimal right here is important. A 0 before it doesn't matter. In fact, if I put a 0 after at the end here, that wouldn't matter. This number right here is still 58 hundredths. This end 0 doesn't matter. But this one that comes right here, if it's directly after the 0 and there's numbers that follow it, it's very important because it holds place value. Okay, 2/10 would be entirely different than 27 hundredths. Okay, let's look at that. 2/10, right? This is a totally different number on 5 than we had on 4. 9 hundredths. Okay, it has to be in the hundredths place value. That means I need a 0 in my tenths place value, and my 9 goes in my hundredths. Okay, 6 thousandths. So I know I've got double zeros because I got to get to my thousandths place value and put my 6. 71 hundredths. Okay, 90 hundredths. The cool thing about this is I could cross both of these out, and 9 tenths is going to say the exact same thing. Watch. 90 hundredths or 9 tenths. Exact same number. I just don't have that 0 on the end. The 0 does not matter on the end of a number. It does nothing for that number. It does not make it bigger when it's after a decimal. And I know that's different than when we're talking about whole numbers, so just bear that in mind as you go. 843 thousandths. Hope you guys are saying these with me as you're watching the video. If you haven't been, start saying them. So this number would be, good, you said 5 tenths, I hope. And this next number on 12 would be, I hope you said 4 hundredths. So I need to put my decimal, I need to put a 0 because that's the tenths place value, and then put my 4. This number on 13, 1,000th. So I need 2 zeros. Okay, those hold the place value of the tenths and the hundredths. The big thing after decimals is they all have this fantastic THs. Notice this? It's on all of them. So you know place value when you hear it, and you know what number somebody is saying by that sound. 45 hundredths. Okay. 15. Say the number. 896 thousandths. 16. 58 thousandths. All right. So you see, just by saying it, saying that number can totally help me figure it out. Let's try a few that are actually story problems here. A large building has 1,000 windows and 5 of the windows need to be replaced. What decimal number represents the number of windows that need to be replaced? To me, it's easiest to write this as a fraction to start with. So I know that the whole number of windows is thousands, right? There's 1,000 windows. So I'm going to write that down. And I know the ones that need to be replaced are 5. So 5 thousandths. And now I can write that as a decimal. Okay, 0, 0, 5. 5 thousandths. Okay? Same here. At a reception, 23 pieces of 100 pieces of wedding cake have been eaten. What decimal number represents what's been eaten? 23 over 100. So 23 hundredths. So when I say it that way, 23 hundredths, I can also visualize what my place value is going to be, 23 hundredths. Okay, Jody made 10 party invitations. She mailed 4 of them yesterday. What decimal representation is that? Well, 4 out of 10. 4 out of 10 can be written like this, 4 of 10, 4 tenths, decimal format, 4 over 10. Okay, so there's lots of ways to say fractions and decimals. With a fraction, you can say 4 out of 10, and you're still saying 4 out of 10, 4 of the whole, right? 10 is the whole, 4 was there. 4 tenths would be another way. 4 tenths is also the decimal version of it. There are 1,000 vehicles in a stadium parking lot. 422 of them are trucks. What decimal number represents the trucks? Well, 422 out of 1,000. So if I say 422 thousandths, the way I would say that fraction, then I can hear it and see it as a decimal. Okay, so really the important thing is knowing zeros at the end don't matter. Think about your place value. Always refer back to this place value system until you're really comfortable with it, guys. No problems with that. You know there's one up in the classroom as well. And let's just get comfortable saying those. Let's not ever hear point when we're referring to a decimal. It is not a point. It says something. If there's a whole number in front of it, it says the word and. If there's no whole number in front of it, then we just say the number and its place value.